Okay, so here's an example of a column with lateral bracing. So it has a bunch of words. So we have a long, slender column, ABC here. And it's pin supported at the ends and compressed by an axial load, P. So we're probably going to find P critical. Lateral support is provided here at the midpoint at B. And it's only provided in the plane of the figure. So if that means if it tries to bend in into along the page, it can only bend halfway. All right. So that's in the plane of the picture there. Then we have lateral support perpendicular to the plane is provided only at the ends. So that means if this bends out of the page, so if it comes out at us, it's going to be able to bend the whole length. And then this would be bending out at us. Okay. The column is constructed of a steel wide flange section. It's a W8 by 32 or 31, and it has a modulus of elasticity of 29 times 10 to the third KSI. And then the total length is 25 feet. And we're supposed to find the allowable P using a factor of safety of 2.5. So we have a bunch going on here. So let's just start with our givens and work our way through it. So given it has pinned ends, and that means K equals 1. So that's good. We have a W8 by 31. So we can go to our tables for our two elastic moduli. We have a full length of 25 feet. And then we're given a factor of safety that's going to be 2.5. And we're supposed to find P allow. So the allowable load, so this won't buckle. Okay, so we're going to use a P critical equation. And as I've discussed with some of you, this is the easy part, and the hard part is deciding what goes into it. So pi squared times elastic modulus times moment of inertia. We're going to have two directions, so 2 moment of inertia times a quantity k L squared, but k is 1. Okay, so we need to look at both directions. And what is going to change in the two different directions is the I and the L. In one direction, we'll be bending around the x-axis, so we'll use IX. And in the other direction, we'll be bending around the y-axis, and we use IY, and we need the corresponding length. So we have the flange is facing us, and the web is facing along, along the plane of the page. So when we're bending around X, that's when we'll be using the whole length. So we'll be bending it would be like trying to twist this end away. And so then we'll have Ix and the full length. When we're bending around Y, so when we're bending around here, that's when we're bending in the plane of the page, and we'll use L/2. Okay, so when bending out of the page, can bend the whole length. And it is bending about the x-axis in the cross-section picture. So we're going to use Ix with L equals 25 feet. Okay, then when bending in the plane of the page, it can only bend L/2. Can only bend over L/2 because it's braced halfway there. So it's L/2, and it's bending about Y. About the y-axis. So we'll use IY with L equals 12.5 feet. So that's the hardest part of the problem, is figuring that out. So now what we do is we go to Appendix B of our book. Which I've taken a screenshot out, and we'll get Ix and we'll get Iy. So that's here. And I guess I've already highlighted it, and we can see that our axes match up. And we have an Ix of 110, an Iy of 37.1. So Ix is 110 inches to the fourth. Iy is 37.1 inches to the fourth. Now we have to calculate a P critical for bending about X and a P critical for when it's bending about Y or deflecting about Y, however you want to think about it. So P critical X equals pi squared. So elastic modulus is the same, 29,000 KSI, times this one has Ix, so 110 inches to the fourth, all over the whole length. K is 1. 1 times 25 feet times 12 inches per foot. All of that squared. And we get 350 kips. All right, now we have to look at the y direction. P critical y equals pi squared times 29,000 KSI times IY is 37.1 inches to the fourth, all over. 1 is K, 12.5 feet is our length in this direction, times 12 inches per foot. All of that is squared, and we get 472 kips. So in this case, smaller value controls, well, we're not going to put a box around this, but we're going to use P critical X as our limiting value, 350 kips. We're going to divide that by our factor of safety to get our allowable P before it buckles. So P allow just equals that ultimate load of 350 kips divided by the factor of safety of 2.5, and we get the allowable load is 140 kips. So once you get through figuring this out, then you plug in, looking at the two different directions, pick the minimum value that controls, and if you're supposed to find P allow, divide by the factor of safety. And you're good to go.